Right guys, today we're going to be looking at investigating the law of reflection. So we need plain paper, a ruler, a protractor, pencil, a ray box connected to a 12-volt power supply, and it's been adjusted so that the beam of light it produces neither spreads out nor converges, so that it's a parallel beam. So I'll just adjust it back to where it was, out there. Now for experiments with light we want a very narrow beam that we call a ray, and to do that we're going to use a single slit. Obviously if we're going to look at a plane mirror, then we need a plane mirror. Right, so the first thing to do is to draw the position of where the mirror is going to go. So we start by drawing a straight line with the ruler, and then we just hatch the back side of the line to represent the back of the mirror. Next, place a little dot on the middle of where the mirror is going to go, and we're going to use a protractor to mark off a normal from that point. A normal is a line at 90 degrees, and we're going to measure various angles of incidence off, and we count the angles of incidence from this normal. So we ignore the marks on the protractor and apart from the actual angles, and measure to here 10 degrees, I'll put a little mark, 20 degrees, 30 degrees, 40 degrees, and we're going to go up to 50. I'll put on 60 as well. So 10, 20, 30, 40 degrees from the normal, 50 and 60 degrees from the normal. We can then use the ruler to mark in the normal. Now it doesn't matter if it goes through the mirror, but I'll mark it in as a dashed line so we can see that that is the normal. And I'm going to write beside it, normal. Putting my pencil on the 10-degree mark, I'm going to draw that to where the normal meets the mirror. The same for 20 degrees and all the other angles. Now these are going to be the paths that the incident ray takes, so I'm going to mark with an arrow the direction that the ray is going to travel, and that direction is towards the mirror. So remember, that angle there is 10 degrees, that one there is 20, 30, 40, 50, 60. Next I'm going to put the mirror in place. Now the reflection takes place on the back surface, the silvered surface of the mirror. It doesn't take place as much on the front surface. So what I've got to do is make sure from looking above that the back surface of the mirror is totally along the line that I've drawn. Now at this point I'm fairly confident that's in place. You can just about see it from the angle. If I move the camera you may be able to get a better perspective there to see that it is along the back surface. Now I take the ray box and I'm going to adjust it so that the ray travels down the 10-degree line. Now if I'm out by a degree or so, then the reflected ray will also be out. So I might move the paper a little bit to get it as perfect as possible. Once I'm happy that it's travelling down the normal, I mark the reflected ray with a little cross close to the mirror and further away from the mirror. I'm going to label those with a little 1 to remind me they're the 10 degree one. I'm going to now move to 20 degrees. Take your time. You've got to remember also that the ray box contains a lamp, and that can get very hot, so you've got to be careful touching the ray box. So there's my 20 degrees one. Put my cross just over here, and another cross over there. 30 degrees. When I'm happy that it's perfect, or as near as perfect, I'll mark it. So that's the 30 degrees. Degrees coming up. Pretty sure that the ray is straight down. There's number 4. 40 degrees. Remember, you need 2 points in order to draw a straight line. And the 60 degrees, a bit harder because the camera's in the way of the ray box. So I'm going to try and move the whole lot over slightly. That looks as if it's the 60 degrees. So 0.6. Right, I can now turn off the ray box since it's going to be quite hot. Let it cool down and remove the mirror. Now I can draw each one of these lines on. I'll soon see how good they are because the 2 lines here, 2 crosses, should produce the ray and it should hit at the same point. So that one looks okay. The one that came from 20 degrees incident, and I'll put that on and see if it is any good. There we go. 30, joining the 3's up. The angle of incidence that was 40 degrees, joining points 4 up, points 5. Oh. There's points 5. Point 5 doesn't look so good. That one might be out. And point 6. Again, point 6. That one, whoa. No way does that go back to the mirror. So these 2 are probably not drawn very well. Take the protractor again. I can place it on the normal. So now I can count the number of degrees. So that's 10 degrees. Alternatively, of course, I could turn the protractor that way around and line it up, and it might be easier to read it, making sure the 90 is along the ruler. So that angle there is 10 degrees. The angle here, the next one, over to here, is 20 degrees. To here, that seems to be 29 degrees. Here it seems to be about 39 degrees. Here, where I said it was looked as if it was off, 48 degrees. And this one, which actually was intersecting over there, so I should really move it a bit more. Seems to be giving an angle of 60 degrees, but that one I can see doesn't go, so this is going to be anomalous. So I'm not going to use it. But we can see there that the angle of reflection here is 10, 20, 29 degrees, 39 degrees, 48 degrees. And to verify the law of reflection, we expect that the angle of reflection is equal to the angle of incidence. So here, definitely true. Here, plus or minus a degree. Using a protractor, it's easy to be out by a degree, so that seems to be okay. I'll check that one again, check this one again, and this one is within tolerance. This, as I've said, very bad, and that was the one where I started to move everything. Maybe the mirror slipped. Okay, we'll finish there.